Hi there, how are you doing today? Namaste, good morning, afternoon, wherever you are. My name is Vishnu Dutt and I work as a network architect in Cisco. We are going to discuss slightly deeper about the protocol, which you can say is used to exchange routes in SD-WAN, right? And that protocol is overlay management protocol. We are going to go slightly deeper into that, right? Then there is one concept in SD-WAN which I feel people generally don't get, and the concept is network address translation. And believe me, guys, it is no different than whatever we know as normal NAT. So if I say that there is a problem in understanding NAT in SD-WAN, I would like to say there is a general problem of understanding NAT, right? That is not related to SD-WAN because nothing is new there. If you know NAT well, normally SD-WAN should not be a problem, right? But I see people have a lot of issues with this concept when they talk about that there are some tunnels which are not forming, right? And if I say tunnel, I'm talking about data tunnel in this case, right? So I could see a lot of engineers here also that who are not feeling comfortable with NAT, and then basically they always complain that there are some tunnel which are not coming up, and there is a valid reason for it, right? We are going to go a little bit deeper into NAT also. Okay. Then the third concept is direct internet access, right? And when we were discussing in our first or two sessions, right? And I informed you that currently, because of the security, or you can say policies of the enterprise, a branch traffic has to go to data center to access the internet, right? Which is unnecessary in some of the cases, right? And how we can achieve that a branch can securely reach internet without going to data center. Basically, we are going to see this, how we can do direct internet access from the branches. So although these are only three concepts, but believe me, guys, when we go slightly deeper, uh, they will cover the entire 2 hours. And whatever we are learning in these sessions from 8 session onwards, those are directly related to our design, right? So basically NAT, DIA, when you go and talk to customer about the requirements, right? Uh, some of the requirements are directly fitting into these concepts only. If you know NAT well, you know which data tunnels are going to be formed exactly, where exactly you need to solve some of the issues with respect to NAT so that you have your direct IPsec connectivity, right? Similarly, direct internet access is the use case, and that is why this feature has come into SD-WAN. So please pay close attention here. Ask as many as questions you want, right? And I would be happy to answer. But the agenda is simple. We are going to discuss OMP. We are going to discuss network address translation. And finally, we are going to finish with direct internet access, overlay management protocol. So first thing first, I want you to have a closer look of this diagram, right? Everything is there. We have understood the concept of T-lock in the last class, right? The topology is simple, and this is exact topology which we have in our lab also. I forgot to upload the lab file, which is the topology file of this EVNG. I will be doing that today when I advertise this video. All right, I will be uploading the image file, topology file, so that you can import in your lab. So we have three things here in this network. We have data center. We have two branches. One is Delhi branch, and the other one is Bangalore branch. If you pay close attention, that we have on the services side, VPN side, we have three routes: x dot x dot x dot 0, which is here, the route which is present in data center, right? Here we have y dot y dot y dot 0, which is route present in Delhi. Similarly, we have z.z.z.0, which is route present in Bangalore. Simple. Okay. Now, I have in the last class, in the last session, we have introduced the concept of TLOC, which is nothing but the TLOC is composed of three things, right? The system IP address, and the system IP address for this VH1 in data center is A.A.A.A, right? VH2, which is in Delhi branch, this is going to be B.B.B.B, and similarly here, C.C. I am going through this topology because it is really important to understand, right? Do not think about these routes at vSmart for now. We are going to be a little bit deeper into that, right? And then I have drawn two transports here. One transport in blue color, which is your internet. One is in green color, which is your MPLS, right? And on each transport, I have mentioned IP addresses, right? And it is my bad that I have put public IP address on the MPLS, but because I have a proper drawing now, so let's assume that this 1.1.1.1 /24 is the IP address I have configured on this interface, right? And this interface, although it should be private because it is MPLS, but I have drawn means I forgot it completely, right? But try to assume that these are the two IP addresses I have configured here. Similarly, on the internet edge, I have configured few addresses. So we have color. If I say green color, it means that I'm talking about MPLS. If I say blue color, I'm talking about internet, right? And if I combine this with system IP, then I can easily identify which router I am talking about. For example, if I say I am talking about C.C.C.C, right? What is C.C.C.C? It is the system IP of VH3, right? And then if I talk about color blue, it means that I am specifically talking about a one IP address or one transport, which is internet transport, and which is exactly this interface, right? I think this is very, very simple. If I say I'm talking about B.B.B.B, which means I'm talking about Delhi VH, right? And I'm talking about green color on it, then it means that I am talking about this IP address, which is 2.2.2.2. Right? Transport locator is nothing but they are just identifying a link, an IP address. Okay. So what happens when you bring up all these edges up and running, right? What is going to happen? The first thing first, these edges are going to make DDNS tunnels with vSmart. And this is exactly what I have shown in green color. I have drew this diagram many times. I have explained this diagram many times because I want you to have this picture at least in your mind whenever you think about SD-WAN, right? We are going slightly deeper into this. So if we have DTLS tunnel, if we talk about this tunnel, right? If I talk about this green color tunnel, which we just formed, it is nothing but a secure connection. And why it is secure? We have an entire session on it because it contains certificates, everything is authenticated, and whatever we are sending inside this tunnel is encrypted. It means that we have already built a secure channel between these devices, right? And we call them as control connections. If I may say, these are control connections. TTLS proves that these are secure, right? Or it might be TLS, it might be DTLS. It's up to you. Whatever you want to configure, you can do that, right? But by default, in SD-WAN, everything is DTLS in terms of control connections. I will always show these control connection in green color and the data connections in yellow color, right? Now our topic, overlay management protocol. Once we have the secure tunnel, right, we can run any protocol inside it. And that is exactly they are saying. Because we have connection to the vSmart, right, we can make a connection, we can make a neighborship over the secure tunnel of OMP, right? If I don't talk about OMP, if I talk about two routers, right, and if I want to run a protocol between them, I'm talking about an IGP, right? Maybe OSPF. First thing first, they form is the neighborship between these two routers, R1 and R2. It is as simple as that, right? Now, this link is analogous with this uh, point-to-point DTLS tunnel. And on top of this link, we are running neighborship of OMP, right? So it means that if I have a secure tunnel already, then I can run anything on top of it or inside it, you can say. So I have shown this with this orange color, which is your OMP neighborship, which is going on, right? Similarly, as I mentioned in the last class, that basically netcon protocol for which, for example, if I want to configure something in vmanage, which is going to instruct vsmart that you need to push only these routes, and how it is going to do that? This is going to do that over the netcon protocol. So whatever vsmart wants to send an information to VH3, VH2, or VH1, it sends it via a protocol which we call as network configuration protocol, right? Which is used to configure networking device. It is not dependent on Cisco's XC or VHCH. It is the standard protocol which is used to configure network devices, right? And now, if you want to send it safely to these VHs from vSmart, we again have this tunnel. So this tunnel can be used for the OMP. This tunnel can be used for your netcon. And also this tunnel can be used for key exchange. And what is the meaning of key exchange, right? So we will be discussing that. But for your information, if we have this secured tunnel at the first place, which is going to be, because it is built in the solution, whenever your VHS comes up, first thing first, they go and ask vBond, and then from the vBond they ask, what is the address of my vSmart? Once they get the address of their vSmart, they will form DTLS tunnel, which is secure, and on this secure tunnel, they are going to send many things, right? First thing, they are going to create OMP neighborship. And exactly when you create the neighborship between two routers, what is your purpose? You want to send routes, whatever routes you have here, you want to send here, and whatever route you have here, you want to send it here over this neighborship, right? Similarly, we are going to do this. We are having green color tunnels, and on the top of it, we are going to run OMP, and in OMP, we are going to send updates, right? It is as simple as that. Once we have this tunnel, now this vSmart, right? vSmart is an intelligent device. Once these OMP tunnels are up and running, and believe me guys, you do not need to configure any single command for that. This is built into the solution. Whenever DTLS tunnels comes up, okay, these OMP neighborships are going to come up on their own. Once they have comes up, they will start sending their service side routes. And what is the service side route? Whatever you have configured, right? Whatever you have configured on your service side VPN. So in the last class, I mentioned that this router, the VH router, is divided into two parts. One is transport side and the other one is service side. Transport side VPN is nothing but the VPN 0, right? And the service side VPN is anything except VPN 0 and 512. 512 is reserved for management, 0 is reserved for transport. And whatever else we have, we can use it as the service side VPN. And whatever the routes in service side VPNs, right? We are going to advertise this into OMP over this tunnel. So right now we have this route x.x.x.0 in data center. Once these tunnels are up, we are going to send this route into OMP, and it will be exactly here. As simple as that, right? If I am going to send it to OMP, OMP is neighboring with only vSmart, right? So all the routes of my complete and entire topology will be with vSmart exactly here, right? So it means that vSmart is learning this route x.x.x.0, right? Via two places, via two T-logs. One is A dot A dot A dot A dot A over the green color. And basically we identify TLOC with 3 parameters. I mentioned only 2. System IP, because this is always going to be IPsec. Or, the protocol or the solution says that it can be GRE, right? But it is by default it is IPsec, and we do not want GRE because GRE there is no security over it, right? It is a plain point-to-point tunnel. So we always say it is IPsec. It means that if I say x dot x dot x dot 0 is learned over this, what is the actual meaning of it? The actual meaning is that I am learning it over MPLS transport, right? Which is having this address. Similarly, this route vSmart is going to learn via another transport, which is blue color, which is indicated by this IP address. These are very, very important concepts. Right? Now I'm talking about path selections also, because right now vSmart is carrying this route from 2 transports. Similarly, the y.y.y, because VH2 Delhi is also connected with 2 transport, MPLS and internet. That is why whatever the service side routes it has, service side means the routes at the LAN side, these are going to be learned via 2, right? Via 2 TLOCs, which is green and blue, and that is why 2 addresses are here. So what is the meaning? Actually, if you can say the final route is going to be same, which we all know. We have route, we have next hop, right? So what is the concept of TLOC? Exactly, it is going to tell you one number, right? Which we are having here. So the common structure is going to be similar. X dot X dot X dot 0/24 via a particular IP address, which is 1.1.1.1. But this address can be changed. That is why SD-WAN doesn't talk about this address. SD-WAN solution talk about this TLOC. That is it, right? So basically, what are the functionalities of OMP? OMP helps in transporting V routes. What are the V routes? V routes or virtual routes are nothing but your transport side, service side routes at each branch, right? They are also responsible, the OMP is also responsible for exchanging TLOC information, right? If I say they are going to send simply these routes, right, with some attributes, and they are going to send this TLOCs also, and they call it TLOC routes, right? It means that this VH1 is going to inform vSmart about all the TLOC it has, right? And what all the TLOCs it has MPLS and internet, right? And whatever the associated parameter. I'm not saying name of these system IPs and color once again, right? And then one more thing it transfer is the service route. This is slightly different concept, which is a part of service chaining. I just wanted to include here, but we are going slightly deeper because some customers has those requirements. So we are going to discuss this in our design sessions. Okay. Very simple. Do not worry about nothing advanced in it. It is as simple as this. And we are going, because there is a requirement for the customer, and that is why we have service chaining included in SD-WAN solution. But do not worry about it. The other thing is basically it is capable of route redistribution, right? And the path selection. The path selection parameter, if you know the BGP, there is a step-by-step algorithm to select a path when you have 2 routes, equal routes, right? From 2 different places. How you are going to select the best path, right? By default, BGP has, I would say, 4 routes. It can install the 4 routes and it can load balance across them. Similarly here, but it has the capacity to have routes till 16 same route across. It can load balance, but do not worry if my last statement doesn't make any sense. Okay, so just like whatever we have path selection algorithm in BGP, we have something similar in OMP. You just presume OMP is a stripped down version of BGP. If you know BGP, there is not going to be a problem. But yes, we are going to see how we can manipulate path. Okay. So what I mean, if I say route redistribution, what I mean is if you are running, say, OSPF at your service side, right? in SD-WAN, you are going to run OMP. By default, OMP admin distance value is 250, right? And here, if you can say OSPF is 110. What you can do is you can redistribute whatever the OSPF route in your service side into OMP. And of course, if you have a big infrastructure here, you can import or redistribute OMP route into OSPF. And it is required, it is necessary. By default, all your static routes and OSPF routes, which are internal routes or even routes, not even, sorry, intra-area route, those are advertised into OMP on their own, right? You do not need to do. If you have a static route, whatever you have configured here, static connected and the OSPF intra-area routes are going to be advertised on their own in OMP. You do not need to redistribute. But yes, if you are running BGP into your service side, you need to redistribute these BGP routes into OMP. And similarly, if you want to have OMP routes into your BGP or OSPF protocol, you need to define it, right? With that, I am going to stop for a while. I am open for questions. Guys, time to ask questions.
So in this scenario, Vishnu, where you have explained that V route via A green, a T-lock A, and T-lock again AAA via T-lock blue, color blue. So it
Correct.
means that in your diagram, you have only mentioned that the VH1 is establishing a DTLS tunnel with vSmart in green. And but you haven't shown the DTLS tunnel is also established between the tunnel is one, however the T-locks are different. Is that way, or there is another tunnel should have been shown? I mean, by default, two tunnels are. Number of tunnels established between VH and vSmart depends on the number of T-locks, right? If there are 4 T-locks, the 4 tunnels should be there between VH and vSmart. Is it like that way?
Actually, the question is absolutely brilliant. And the answer is, Ashish, if you can see, vSmart is only connected to internet, right? In this scenario. Okay.
Right.
So whatever is the transport, doesn't matter. If VH can reach to vSmart over the transport, it will definitely form a control connection. Okay. Right now from MPLS, there is no reachability. That is why I haven't shown the control connection over MPLS. But it does try to create a MPLS. It does try to create a control connection over MPLS also. But the point here is not this. Point here is if we should have at least one tunnel, only one tunnel, one control connection from this VH, which is always required. For example, if you have say 2 BGP neighborship or the 2 OSPF neighborship here, it doesn't matter. You need to learn route, right? Because in normal routing, basically you are actually sending traffic over this links. But these are not the links where we are going to send traffic, right? This is just the way the control connections is just the way to pass some control information along with OMP, right? Once this is done, then we create the data tunnel, which are the separate links totally, right? So that is fine. VH is going to make this DTLS connection to vSmart over every transport which is reachable to vSmart, right? But if there is no reachability, then there is a problem. At least you should have one transport over which vSmart could be reachable. Am I able to answer your question, Ashish?
No, but basically, I could understand this that if I talk about the green T-lock x dot x via AAA, I'm able to I'm able to understand 1.1.1.2.1 IP because that is connected via internet, right? But the thing, and you have also shown the tunnel in green color as well with vSmart
Okay, I got it. Okay, I got it. What you asked.
The MPLS part is
is not clear.
1.1.1.
Okay, I got it. Okay, I got it. Let me take an example in our normal routing protocol, right? Suppose if I have Yeah, suppose I have a OSPF router. Ashish, just pay close attention. Okay, very important thing which you have asked. And if I have two connected routes here, right, and I am making a BGP neighborship with another router here, this neighborship is up, right, Ashish?
Mm-hmm. Mm-hmm.
What is going to happen? Suppose this route is say not R1. Say this is route is connected one C1. This is C2, and the link on which you have created neighborship is C3, right?
Mm-hmm.
Now, when you advertise the routes from R1 to R2, do you advertise only C3 or it depends on the configuration? Depends on the configuration of OSPF, right? If you have included these two routes also into the OSPF configuration using network command, it is going to advertise these two, right? But your neighborship is forming on C3 only. It doesn't mean that it is going to advertise C3 only.
Mm-hmm.
If you have included C1 as well as C2, these are going to be included. Agreed?
Mm-hmm.
Similarly here, we have neighborship over this link, internet transport. But by default, OMP says, or the OMP configuration says, whatever TLOCs you have, whatever, advertise them. You're getting my point?
Mm-hmm.
So it means that although you have a neighborship over 1.1.2.1 here, right?
Mm-hmm.
It doesn't mean that it is only advertising this blue TLOC.
Mm-hmm.
By default, the configuration says whatever TLOCs you have on this vEdge, you need to advertise it. Getting my point?
Mm-hmm.
Simple. So whatever you do not understand, just go to your normal routing because we are not doing anything different than this. But there are some automation involved. As I mentioned, you do not need to configure OMP neighborship at all, right? It is built into the solution. And how it is built into the solution? Whatever TLOCs you have, maybe there is one more transport locator of maybe another internet connection, maybe other MPLS connection or LTE link, 4G link, right? Whatever you have, just advertise it,
Mm-hmm.
right? And if you have a TLOC which is in present working condition, then obviously this route is reachable over it. Okay. Other questions, guys. But Ashish, brilliant question actually.
Vishnu, I missed it. So this blue one is a data tunnel or what?
Which blue one?
This blue which you are showing, this blue. There's green and blue. Green is a control tunnel.
Green is a control connection. I haven't drawn any data tunnel till yet.
This
Whatever
is
the other link.
blue one which you are referring. This blue.
Which okay, this blue. Okay, this
The
color.
Ethernet
This is
link.
basically the color. This is the color which I have configured, right? So basically, to identify TLOC, there are two things, Murli. Right? One is the system IP. The system IP is this one, A.A.A.A. And I have to go into this interface and tell what is the color. I have shown this in green color, so I didn't mention, but this is the color which is green color here. And this is the color which I have shown in blue color. So actually you need to go and configure. And why we are doing this? Just try to understand the concept behind it. We have a router in which we have several transports. Maybe this is LTE, this is MPLS, and this is internet. How I'm going to identify this link? You can say simple, whatever your IP address you have configured here, but this IP address can be changed, right? So this is why I'm not going to identify this link with an IP address. I'm going to advertise this link with TLOC. And to do that, what I have done is first identify this router. What is this router? Maybe this is 1.1.1.1, right? Second, identify the color you have configured on the interface. Suppose on internet, I have configured green color. Sorry, blue color, right? So if I say 1.1.1.1 blue, what does it mean? 1.1.1 means I am talking about router R1. Blue means I am talking about specifically this link and not this and not this. TLOC is just a way to identify your link guys on a router, right? So if I say I have learned two routes x.x.x.0, via 2 transport, it means that this router has 2 transport where this route can be reached. Okay. Anybody else?
Vishnu, I have one quick question. So
Yeah, please.
how many T-logs is available? Depending on that, there will be that number of data tunnels as long as the next hop is reachable, right?
Indeed, and I'm going to discuss that thing next.
Oh,
But you
okay.
are right.
Okay, got it. Because there is no connection from MPLS to vSmart, right?
Yeah,
Direct
it shouldn't be. See,
okay.
again, I have taken this example. Just remember your normal routing, and that is why I say if you are solid in your normal routing stuff,
Got it.
SD-WAN is nothing, right? Because
Got it.
you do not need a
Yes.
neighborship over these two guys, right? As simple as that.
Yeah, as long as the underlay is up, then there will be an overlay tunnel. Okay, got it.
Right. So what is happening, guys? I'm pretty sure that you all are very comfortable about this diagram. And if you are not, just go through this recording again and again, unless you get everything out of this diagram, right? This is really, really important. Normal routing, nothing else. Okay. But I'm getting some good questions. So what happens? VH comes up, they make tunnel with vSmart, and the tunnel is called control connection. Those are secure tunnel. If those are secure, I can run any routing protocol because nobody is going to see them on the internet because that is secure, right? Secure with certificates, secure with encryption, right? Once it is done, I can run OMP protocol, and when OMP neighborship comes up, the first thing first, it always exchanges TLOC information and virtual route. Virtual routes are nothing but the routes configured at your service side, right? Once done, this vSmart is having complete picture, complete route information of your fabric, right? If I say, suppose this is a very simple example in which you have only 2 branches, 1 data center. What if you have more than 1,000 branches? It is going to be the same. OMP will come up and VH is going to send all TLOC information to vSmart and all whatever the routes you have redistributed into OMP, right? They are going to tell everything about vSmart. Now vSmart is having this information. It means that now whatever the changes you want to do, you do on vSmart. Suppose, for example, if you do not do anything, what is the default behavior? Whatever the routes this vSmart is learning from everybody, it is going to send them back over these transports, right? It means that this transport is, not transport. This control connection is connection between Delhi and vSmart. Once vSmart has done all the route, it is going to send all the route information to Delhi branch, right? Very simple. It is going to say that x.x.x.0 is reachable over 2 transport location. Which one? Green color as well as your blue color. It means that it is sending the routes. It means that it is sending the TLOCs. Similarly, here also, it is going to send the routes and TLOC. I do not want to write all the routes because it is going to clutter the complete diagram, right? It is going to have TLOC and TLOC of what? TLOC of other side. Everything information means for green, suppose it is sending the data center route. Which is x.x.x. It is sending that it is reachable over green color. Green color it also has, but where exactly on the green color? It is saying it is reachable over this IP address, not IP address, this system IP, right? A.A.A.A. Once this guy reach all the TLOCs information, it means that now it can create data tunnels because it knows that what are the TLOCs available in my complete organization. And how did it know? Because to this Delhi branch, this guy by default is advertising everything. If it is advertising everything, it is advertising vRoute, it is advertising TLOC information, right? So at the end of this activity, this Delhi knows what are the other T-locks available in my system, transport locators available in my complete system. It knows that on VH1, right, there is one green transport, one blue transport. And how to reach it? It knows all the information because it know. Because vSmart know. And if vSmart know, it is transferring all the information. Okay. So if I say, if this Delhi branch and Bangalore branch and data center knows each and every T-lock, isn't this information is sufficient enough to create the data tunnel, right? If this VH2 knows that there is another transport which is on VH1, let's create a data tunnel. Here is a data tunnel, right? There is going to be another data tunnel over another transport like this. Getting my point, guys? There is another tunnel directly from internet to this guy. And similarly, because this guy is connected to here, there is another tunnel over this internet and like this. Am I clear? Because vSmart is sending all T-locks information, all virtual route. And for data tunnels to come up, everybody should know what T-locks we have in the complete system, right? So if there is a reachability between two T-locks, the first thing first, after control connection, these branches or data centers routers will do, they will try to form data tunnel, which is your IPsec tunnel, right? And it is full meshed in nature. Whatever the T-locks they know, they will just go and create a connection over it. Questions, guys? I am again stopping because this topic is really, really important.
Vishnu, Ram here.
Yeah, Ram.
Vishnu, for the redundancy purpose, if I put one more vSmart, the table you wrote over there, it will reflect multiple times, or like in BGP, we have a client ID, cluster ID to avoid the loop. Is there any such techniques over here?
Yes, there is. So basically, if you have, so I just wanted to have this diagram little bit, what we can say, simple enough, right? Because if you understand the working of one route reflector, you can understand the working of 5 route reflectors, right? So if I include one more is vSmart here, that is fine. And there is a control connection going on between these two, and OMP is running between these two. Just like route reflectors, right? If you have 2 route reflectors in BGP, there is going to be IBGP between them. And whatever the route you are learning, you are reflecting back. Whatever the route you are learning, you are reflecting back. But this guy is intelligent enough. It is saying that because the same route reflector is not going to change the next hop, right? It is always coming for, and this is exactly happening here. So although you can have many vSmarts, but these guys are going to get only this routing table. That is it. Because the next hop is going to be same, right? X dot 0 for this vSmart or for this vSmart is going to be same because it is always going to be learned via this. If I say this is the part of data path and they are changing the next hop, then it makes sense that it is coming from different vSmart. But if they are not just doing nothing, whatever the routes they are getting, they are just advertising it, right? And this guy is intelligent enough. It is going to take care over see.
No, in BGP, Vishnu, if both the route reflector having the same cluster ID, then it avoid this one duplication. If you give different ID, it will install that route. You agree with me?
I do agree with you. But here, actually, if I say that, suppose I have a vSmart 1 here, it is going to advertise this set of route, right?
Okay.
You agree?
Correct.
I have vSmart 2. This is again going to advertise only this route, nothing else. So this guy is intelligent enough to know that we have 2 vSmarts and there is no point of installing another set of route because these are not. You are getting my point. This is good. Any other questions, guys? Rohit, Murli, Vanchi, are you guys comfortable with this concept? Satya?
I am good, Vishnu.
Yeah,
this is fantastic. This is good. Okay, so now let's discuss something in terms of path preference, right? See, I can teach you the algorithm, how to select the best path in OMP, right? Similar to BGP. And most of the times we know only few parameters like local preference, AS path, how to tweak route with it. And believe me, although there are many parameters in BGP to tweak paths, right? For the traffic engineering, one path should go like this, one path should go like this. But in most of the implementation, which I have seen in my career with most of the clients, right? They're always going to use only few parameters. One is local preference, the other one is AS path, and sometimes in case of service providers network, they play heavily with communities, right? And believe me, guys, I haven't seen much more parameters to be used in production, right? So there is no point of going that complete algorithm of OMP one by one and just waste our time. Okay, we will see few things. And if you are really interested in reading the algorithm, just go and read the algorithm of BGP first. And then if you are comfortable with that, you can understand the OMP. But believe me, you are not going to use much of the things there. Whatever we are going to use in the standard design, I'm going to discuss with you, right? So now the question here is, we have two data path from VH1 to VH2. One data path is this, if I say tunnel 1, and this is tunnel 2, right? This board is cluttered, so I have created one more such board. Let me go here. Okay, this is neater. Okay, one question, guys, for you. What is the meaning of this dot dot which I have created here?
Cloud.
Cloud. Okay. Anybody else? Because you should ask this. I think you must have seen the comic characters, right? And if they were thinking something, then they does like this, right? So here basically vSmart is the brain of your complete fabric. So I thought to create this thing because it is thinking a lot, right? And what exactly it thinks, I'll let you know. Now you agree with me that all these branches are getting the TLOX information, and that is why they have created IPsec tunnel. I am just talking about the communication between data center and VH2 or data center and Delhi branch. So we are going to have two tunnels, right? Although I can make another, means the same tunnel once again, right? But let's, for our path selection algorithm, that how exactly it's going to happen, just leave the fact for now, right? And just leave the other tunnels for now, and let's concentrate only on these two tunnels. This is going to be my tunnel number 1, and this is going to be my tunnel number 2, which is between data center and Delhi branch. We all agree that every router is going to create a full mesh tunnel, but what we are going to showcase here is we are just putting our brain in only these two tunnels between data center and VH, right? So now, if I talk about this guy, x.x.x.0, which is lying somewhere here, and if somebody from Delhi region wants to communicate to this route, x.x.x.0, right? It will receive it via two places. It can be reachable over tunnel 1. It can be reachable over tunnel 2. So generally, if we have equal cost routes, right? So suppose I have a router here. I'm going to my normal routing. If I have two interfaces, and if I receive the x.x.x.0 is reachable via this interface as well as this interface, what exactly it does? It ECMP, equal cost multipath, right? It is going to send some flows here. It is going to send some flows here, right? Although it is not going to be a 50-50% distribution because some flow can take high bandwidth, right? But they are 50-50 in terms of a flow. If I say a flow is just nothing but a connection between two IP addresses and port, right? So if I open a TCP connection with some router, it is basically source IP, destination IP, source port, and destination port. A flow can be identified with these 4 parameters, right? And basically the protocol also. So if you can say then if somebody is sitting here on its laptop and if he wants to go with a Google or some other connection, these flows will be ECMP. Means some flows are going over this interface, some flows are going over this interface, right? Similarly, now we do not have links here. We have tunnels here, which are your IPsec data tunnels, right? Which are shown in yellow color. So if we have tunnels here, some flows to reach this guy x dot x dot x dot 0 from y dot y dot y dot 0, some flows are going to be over tunnel 1 and some are going to be over tunnel 2. Everybody agrees with me because we are receiving the equal cost path. But now I do not want that, because if there is a the problem is it might be happen, and I'm drawing this with some other color. Let me choose a different color to showcase the traffic path, right? And I'm going to take maybe this red color, suppose, right? So right now, if this y dot y dot y dot y wants to reach to x dot x dot x dot 0, it is going like this here. And maybe the reverse path could be like this. Do you agree, guys? Right? And if it is happening, if it happens this way, we call this as asymmetric routing, right? Because the if we say one direction, we are taking a route which is different than received direction, right? To go up, we are taking tunnel number 1. To go down for the traffic path in the downward direction, we are taking tunnel 2. And if we have asymmetric routing and if we have firewall somewhere in the asymmetric routing, we are going to get the problem, right? And what that problem is? The problem is this firewall, if it doesn't see the initial conversation, it is going to drop it. And this is totally different topic, guys. Do not worry about it, right? But keep in your mind that asymmetric routing creates some problems, right? So somebody is coming to you and they say, I do not want the asymmetric routing. I want that whatever the traffic you are sending between these two guys should go over MPLS first. You're getting my point? And then if MPLS is not available, just if MPLS is not available, then ship this traffic to tunnel 2, right? So generally what you do, whatever you have a preference point here. What is your preference point? MPLS is going to be preferred link, right? And internet is the second link, or basically you can say this is active and this is going to be backup. Guys, everything whatever we are discussing here is directly when we talk about design. These requirements are nothing but the design requirements, right? Whenever we go and collect information from the customer will doesn't say that how you are going to do this. They will say that I want this link as a preferred, right? Or they can say I want this link to be preferred for these application and nothing else, right? Just try to understand, if you have two tunnels, tunnel 1, tunnel 2, if you do not do anything, it is going to do ECMP, equal cost multipath, means it is going to send flows, one flow over one link, another flow over another link to load balance, right? But if customer doesn't want this, what you need to do, you need to prefer one route. If you want to prefer one route, you need to specify somewhere your preference. And now the question arises, where exactly you are going to specify that preference, right? And that is why I have shown here vManage, exactly here. vManage is the place where you go and let the system, let the SD-WAN system knows what exactly your intent is. And if you say intent, what do you actually want to configure in this SD-WAN solution, right? What is your intent? And your intent is simple, that Delhi always wants to prefer MPLS. This is your intent. Delhi branch always wants to prefer your MPLS link, and internet is going to be backup. So what you are going to say to vManage, Delhi always wants to prefer MPLS. Let's increase its preference, right? So there is a parameter in these routes, just like BGP preference, right? But BGP is a local preference, which is basically valid inside a particular AS number, right? Now, you have mentioned you have logged into the vManage UI, and you have configured that yes, channel 1 is preferred. It means that whatever way, it doesn't matter, right? Let's say the preference selection can be based on a number. If it is a higher number, it is more preferred. So you have configured that higher number for Delhi branch here in vManage. What vManage is going to do? vManage say vSmart is the most intelligent person, right, in this complete fabric. I should tell it because it knows all the route, because it advertises all the routes towards the branches. I should say, and when I say that vManage is going to instruct something to vSmart, it is going to be over some common protocol. And that is why basically network configuration protocol comes into picture. Through network configuration, vManage is going to tell vSmart, please increase MPLS preference in Delhi branch, right? Again, I am repeating, please increase MPLS preference in Delhi branch. It means that whenever you advertise routes to Delhi branch, you need to tell that the preferred way is MPLS and not the internet, right? And that is why this vSmart will say, whenever I'm going to advertise route to Delhi branch, because now I'm concerned about Delhi branch, right? And that is where this site ID comes into picture, guys, right? I'm going to tell vSmart that whenever you advertise routes to site 200, right, make sure that MPLS is going to be the preferred TLOC, right? So this is the configuration it got received from the vManage, and now we are going to make this intent whenever we are advertising routes towards our Delhi branch, right? So as you all know, how exactly things happen, vSmart is going to learn all the routes from everywhere, right? Once it learns, it starts advertising routes back. Now, we have put one condition here, right? Now from because it has received something from the netcon, now it is saying whenever you advertise routes in the outbound direction, and that is why the outbound direction is important. You are telling vSmart whenever you are advertising in outbound direction to Delhi branch, increase its MPLS preference, and that is what exactly it is doing. When it is advertising it, it is having the MPLS preference which is of green color to 500 and the remaining one to 100. So when this route comes here, when this route reaches to Delhi, and this route is only for the branch 200, guys, right? Branch 200 means site 200, and that is where the concept of sites is very, very important. You want to have your similar sites, not basically every site has every branch has different site number, and that is why it is important that which branches you are targeting right now. Okay, so you can define your similar branches between 200 site number and 400 site number, where exactly all these things are same, and you can put the complete intent, whatever, to this all the sites, right? And what was my intent? Intent is I want to increase the MPLS preference in Delhi, right? And that is why I am showcasing here that this vSmart is thinking I got an instruction from vManage to increase preference of MPLS, right? While I advertise route to Delhi site. This is as simple as that, right? And that is why you are going to receive preference. Yeah, go ahead, guys.
Sorry. For the data center want to reach YYY, then it is a ECMP?
Yes. And that is why basically I am just explaining the one part. You need to do the same part there also.
Okay.
Okay. Because right now I'm advertising, I am doing all these things for only Delhi branch, right? If I include that, basically do the same thing, right? For or basically if you want to have there are different mechanisms, but leave that for now, right? just concentrate on what I'm saying right now. But your question is valid.
Okay.
There are different mechanisms that how this data center is, because this is the route for this data center only, right?
I didn't got the point that you are told that from the vSmart to the Delhi data center on the outbound direction, you are telling that preference is high, right?
Yeah.
Okay.
Yes. Outbound direction means, see, I am going to advertise this route always in outbound direction. Do you agree, Ram?
Correct.
Right? It doesn't mean that I cannot change the parameter in inbound direction. If I change the inbound direction parameter, right? And suppose if I want to have two different, and I'm taking a hypothetical example, which might not be the case, right? Delhi, Bangalore, and suppose I have a different branch, which is again having two transport. I want this policy to be implemented only inside 200. Maybe I want an easy MP here inside 300. Right? If I change the preference in inbound direction, that it is going to be changed for everybody.
Everyone. Okay.
Right? Because vSmart doesn't know about what it is, because it is changed when it comes. Right? And then if it is changed, then basically it is advertised in the changed form, which I do not want. Right? So whatever I am explaining there is a special reason behind it. So if you do not get the other point, that is not the intention right now, guys. Right? We will cover those in design section. That is fine. But try to understand this concept that if you have two paths and you need to select it, vManage is going to just try to understand the entire flow. vManage is going to send your intent via netcom to vSmart, and now here you are placing a policy. And by the way, guys, I didn't want to take the name of policy, right? But exactly this is the policy which you are going to implement in the outbound direction whenever you are sending your routes to Delhi, right? And that way, basically, you can set the preference, and that is why the preference is here 500 and 100. Okay, guys. And if it is 500 and 100, then basically, and I presume that 500 is the greater the number, the greater the preference. It means that now this is going to be the backup path installed here, and this is the primary path installed here in the VH2. So your traffic is always going to be via tunnel number 1. And if this goes down, then basically we are going to install the second best route, which is with preference 100. Right? And then basically we are going to take this route. I think we are good with respect to this. Satya, Sandeep, Pankaj. Oh, Pankaj is there. Vanchi, Murli, Rohit sir, Ben, Ashish, anything?
Vishnu, I just have a doubt regarding the site ID. How is it different from the system IP? If I understand correctly, both are unique, right?
Yes, both are unique. You are absolutely correct.
Okay.
But there is IP address planning for these things is a separate thing, and then this number planning is separate thing. But you are absolutely correct that whatever we had done from this site, we could have done with system IPs also, right?
Right.
But believe me, this is going to give you more flexibility in terms of site, because IP addressing, whenever you decide, you do not decide on the basis of, I'm not sure whether if you can plan that well, you can do this on system IP basis. But believe me, generally what we do means as a designer, right? I want to have all my sites. For example, if I am in say if I am in Asia Pac region, right? These sites can be on the basis of region. This site can be basis on their type of TLOX connectivity, right? So suppose I am in Asia region. So what I'll do, I will make sure that I'll start this site ID with a number like 31. 31 is for Asia, right? And then inside Asia, basically whatever I'm part of, whatever. So this number can be huge, long number, right? Now, what it gives me, it gives me the flexibility to write my policies. Suppose I want to have policies implement for entire Asia, and in this entire Asia, there are 500 sites, and I want to implement all the policies on all 500 routes. I just need to make sure whenever I advertise routes to this 31 star, What is the meaning of 31 star? Everything after this 31 could be anything, right? And I can do this with single statement. Although I could have done with the IP addresses also, but they have kept it separate. You design your IP addressing schemes different, right? We have a different parameter for you to identify your site, right? The another parameter of identifying or the site ID is, suppose you have 500 branches, which is having only internet connectivity. You have 500 branches which have internet and MPLS connectivity, right? And if you want to push a configuration, right, you can do that. I know that I have 500 sites from number 0 to maybe 600. Whatever the sites are here, they are only having internet connection, right? So I can configure this internet connection for all the site in a one go, because I know the type of my site, right? Similarly, these sites between 600 or 700 to 1000 have two connections. I can configure between 700 to 1000 in one go. Just presume that we have a different mechanism in our routing also. We have access list, right? We have prefix list. We have n-bar. And what exactly we do from these things? We identify prefixes. Once we identify prefixes, then we implement some route policies or policies over it, right? It is as simple as that. We cannot argue that we should not have access list or prefix. These are just the tools, right? You have different tools. You have system IP for some different purpose, and you have site ID for some different purpose. Hope I'm able to answer your question, Murli.
Yeah, makes sense, Vishnu.
Yeah. Guys, anybody else? Any questions?
Vishnu, I have one doubt. For actually in real scenario, what we will do, we usually to check the status of that link, usually we'll configure the IPSL layer, right, for the continuous tracking. Is there such feature we are doing over here also?
Yes, there is. So whenever we do DIA, right, direct internet access from a branch, the problem is the DIA link can goes down, right? Then we can track using SLA tracker. So there are many, whatever the functionality you have in normal routing, it is already there. And on top of it, they have made it simple through automation. That is it.
So Vishnu, we will configure the BDF on each links. I mean, in terms of both the colors, BFD.
Oh yes, I haven't included this term BFD. No, you do not need to configure BFD. It is going to become up again. So actually, I have so guys, these IPsec tunnels are also known as BFD tunnels, right? But generally, we as a network engineer has some different perception about BFD, right? So why BFD is used? So if we have a link here, we can configure the BFD over it, and the whole sole responsibility of BFD is to check the availability of this link. If this link has some problem, then we can configure BFD over a routing protocol so that when this link goes down, the neighborship goes down. Otherwise, for the BGP neighborship to go down, it is going to take approximately 180 seconds, which is a too much time, right? So BFD is responsible for a sub-second failover. If I say sub-second, it means that less than a second, right? If we do not do anything, then by default, if this neighbor has some problem, then BFD is going to take, BGP is going to take 180 second. And this is what exactly I have perception toward BFD. But if somebody says that we have BFD tunnels also, it means that there is a specific reason of implementing BFD over these data tunnels. And what is that reason is, I'll let you know, because there is another important topic, which is application aware routing, right? Whenever we are going to discuss, we will include the BFD, but for now, just leave it for now, the BFD part. Okay, let's talk about another concept which is most misunderstood. I'm not sure why. And believe me, guys, this is simple. So first of all, we are because NAT is a NAT. If it is an inside SD-WAN technology or anything else, NAT is simply a network address translation. It is a necessity, right? It was bring here to save some of the IP addresses, and because IP4 address space is depleting day by day, right? And network address translation is helping us. And there are other use cases also for NAT, which are pretty wide, right? And if we want to discuss with them, then basically 2-3 classes are going to be required. But believe me, I want to cover basics of NAT, whatever is required in SD-WAN, right? So the topology is simple here. Nothing different than whatever you know, right? So we have a server 8.8.8.8, which is on internet. And now we have a router at the periphery, which is connected to internet at the one end. And on the other end, it is connected to a layer 2 switch. And I'm calling this router as NAT router, okay? Because it is going to perform some network address translation, okay? So we have layer 2 switch here, and over this layer 2 switch, we have two different things connected, right? So suppose this is my organization. This is my XYZ organization here, right? And in this XYZ organization, I have a simple employee here, employee Ace, you can say, which is assigned as a private IP address, which is 10.2.10.10. And then I have a server here also, maybe my website, although it is connected, although it should be connected to a firewall DMZ, but that is fine. For the sake of simplicity, I haven't included much things here. Very simple network. We have router, we have switch. A switch is connected to a laptop, and then this switch is also connected to the company server, where I am hosting a website for my company. And if I am hosting a website for my company, it means that it should be reachable from internet. So if somebody is sitting here on the internet with its laptop, his or her laptop, these guys should be able to reach this server, right? First thing first, if I have a private IP address range, what is the meaning of private IP address range? The meaning is it is not routable on internet. Okay. So if I means if I am sitting on this laptop L, and if I type a address 10.2.10.20, which is the IP address of my server inside my organization, I won't be able to reach it. And the reason is because whenever this IP packet goes to internet with this source address, the source address is going to be 10.20. The internet says that I do not know about it. And by default, it filters everything, whatever is in the private address range, right? You can go and check what is the private address range, but primarily there are three different subnetworks. One is a complete network of NAN, which is 10.0.0.0/8, then 172.16.0.0/12, and then 192.168.0.0/24. These are the three IP address subnets which are private, and anybody can use them in their organization. And that is why basically this 10.2.10.20 could be used with some other organization, right? Because this is private address range and you cannot reach it because it is not routable over internet. And that is where exactly you need to transfer or to translate this IP address into something else, which is reachable over internet, right? So this guy, the XYZ owner, reached out to internet company, and internet company has assigned it some IP addresses, right? Some public IP addresses, and that is why basically I have shown here that it has been given a block of /24, although it is very difficult to get a block of /24 now from ISP of the public IP address. So this is the block it got /24, right? Exactly here. It means that it got approximately 254 IP addresses, which they can configure on their range. So this guy could have configured this. This guy could have subnet this complete IP address, and maybe he might be using /30 here or /31 here, right? And remaining addresses, it can be assigned to servers, but this guy doesn't want to do that, right? He wants everything on the private range on its L2 side, and then want to translate it. So first thing which comes into picture is one-on-one NAT, and what exactly it is. So this guy has taken one IP address from here, right? Which is 20 dot maybe say 20, suppose, right? And it is saying that whenever you receive a request, whenever you see a IP packet from source address 10.2.10.20, which is the IP address of this server, just change this source address. I'm repeating, guys, just change this source address to 20.20.20.20 when it goes out over this interface, because this guy cannot, this guy is not reachable, right? So what is the source IP when the server wants to communicate to this laptop? Or suppose this laptop is having the IP address maybe 9.9.9.9, right? So the destination IP is going to be 9.9.9.9, very simple. And the source IP is going to be 10.2.10.20, right? When it is on the server, when server creates a packet. When it goes to this router is checking its net address translation because you have configured this manually, right? And one IP address has been changed to one IP address at the public side. This is the private side range. This is the public side range. And you are transferring, or you are just translating one IP address to one IP address, one public to one private, right? It means that you are doing one-to-one. And that is why when this guy reaches here and when this packet wants to go out of this interface, the source IP packet, the source IP address is going to be changed from 10.2.10.20 to 20.20.20.20, right? You're getting my point? And then it goes out. And because now this packet is going to reach here with source IP address of this and destination IP address of this, the laptop is going to reply back, right? Very simple. Now the source and destination is going to be reversed. The source is going to be 9.9.9.9 and the destination is going to be 20.20.20.20, right? So basically, I mentioned is incorrectly here. So believe me, guys, destination IP address is not going to be changed in this direction for sure, right? But when this laptop is replying back, to whom it is going to be replying back? It is going to be replying back to this. It means that this will become destination IP and the source IP is going to be 9.9.9.9. And that is why we changed this IP address, because if it was 10.2.10.20, this guy would have dropped the packet straight away, because internet knows that there is no way it can reach to 10.2.10.20, and that is why the first place we changed it to 20.20.20.20, as simple as that, right? Once the packet reaches here, it knows that I have assigned 20.20.20.20 to 10.2.10.20. It means that it is going to change the destination IP once again towards, when the path is reversed, it is going to change this destination IP back to whatever the IP address we have. And guys, this is the NAT. This is simply the NAT, right? And right now, basically all the times, this mapping is there. So it doesn't matter who is initiating the communication, right? This server can initiate the communication. It can say that it wants to reach, instead of it is saying 10.2.10.20, it says this laptop that I want to reach 20.20.20.20, because that is the translated IP address, right? But believe me, guys, this IP address is nowhere, right? But it is under the NAT address translation table. So once exactly it happens, this guy on this link start advertising or start replying to the ARP queries. So when this packet reaches here, obviously this is going to say who is 10.20.20.20.20. Although that IP address is not there, but this interface is going to reply that I am hosting that IP address. Send the packet to me. And this is the function of NAT. So what is the NAT responsibility? It is responsible to translate your source IP address when the packet comes, right? And when it comes from the internet, it is going to change the destination IP address accordingly, right? And the second thing it does is, because this IP address is not configured here anywhere unless on NAT, so it is the responsibility of this 0/0 interface to reply R, right, on the to reply R for this IP address. So when internet asks who is 20.20.20.20, this guy is replying back, I am 20.20.20.20, right? This is simply 1.1-to-1 NAT. No matter from where the communication initiate, it is going to be there. Guys, questions now on this? Because if you understand this, then basically there is no problem with respect to, and there is NAT overload also. If you understand these two things, there is no problem you are going to face when you configure your tunnels in SD-WAN. Although you do not need to configure an internal, but it is there. Did you get it, guys? Now, let's try to understand one more concept, which is NAT overload, right? And how it is slightly different with respect to one-to-one NAT, with respect to the communication, who initiate the communication, right? Now, this company say doesn't have the luxury of that /24 range, right? It gets only one IP address from the service provider, which is 20.20.20.10. And now what it is doing is, and suppose this doesn't have any server also here. So all the employees are here who are in the private address range. And now what exactly they want is to reach out to this server, right? So instead of doing one-to-one netting, right? One-to-one specifying IP address, and those are not saving the IP address also, right? So what we are doing here is we are just transferring, we're just changing the source IP address, all the source IP address with single IP address, which is 20.20.20.10, right? Interesting, right? So basically this is going to be the communication going to be happen on TCP port 80, right? And here the source port could be anything, maybe 1, 2, 3, 4, 5. Source port is random. So what exactly going to happen, guys, here is this laptop here, the user A here wants to communicate to 8.8.8.a, and we have configured NAT here. That NAT is slightly different, and we are calling it as NAT overload or PAT, which is port address translation. Okay, what exactly this is? When the source IP 10.2.10.10 reaches here at the NAT router, what it is going to do is, so basically there are two more parameters now associated with this packet, the source port also and the destination port also. The destination port is going to be port 80, and the source port here I have mentioned 1, 2, 3, 4, 5, any random port, right? It goes here. It goes here, it reaches here, and now I have informed this router, whatever you are getting from this range, 10.2.10.0 range, you just need to transfer the source IP address of each and every packet with the interface IP address, whatever you have. So it has the IP address 20.20.20.10. It is going to replace the source IP this with this one. And then the ports are going to be same or different accordingly, whatever we have. So basically, we are going to talk to port number 80 destination, and suppose we have changed the port to maybe say 73, right? So this is important to know that they have changed the port, or maybe they can have the same port also, right? And then there are some different types of NAT. But believe me, you do not need to go into the address restriction port or the port restriction port. That is fine, right? If you understand this, you are good. So this packet is going to go out on the internet. It is routable for sure because we are going to reach here. It is going here, and then this packet is coming back with the same thing which are changed. Now, this is going to be the destination IP. This is going to be the source IP, and this is going to be the destination port and source IP, source port, right? Now, once it reaches here, it is again start doing translating to back to this packet once again. So the destination port of 73 will be converted into 1, 2, 3, 4, 5. The source port of 80 is going to be remain same. The destination IP is going to be changed from 20.20.20.10 to this one, and the source IP is going to be remain, right? This way it is going to be routed here. But now the important point is the communication can only happen if the initiator of the communication is this host on the inside part, right? And what is the reason for that? So what exactly happening behind the scene? This router is maintaining a table of translations that if something is coming like 10.2.10.10 with some port, say P1, this IP address is going to be netted into 20.20.20.10, right? And with some, this P is translated to P dash. So this table of translation is going to be this in this net router whenever there is initial communication, right? If this table is there, this entry in the table is there, then basically anybody who is coming from outside, right, can be translated back. But my problem is now this server, if this server wants to initiate a communication, suppose first packet is from this server SYN, right? And these entries basically, guys, are time based, maybe 5 minutes, 10 minutes, you can configure this time, right? And when it initiates the connection, the first SYN packet goes here. It will not find any such entries here, right? Because the communication is going to happen from outside. That is why the packet is going to be straight away dropped here. It means that with NAT overload, only one-way communication can happen, right? If that communication starts from this side, okay? If the communication is start this side, then obviously it can reach. And why the reverse traffic is applied? Why the reverse traffic is also permitted by this router? Because they have the entries, right? But suppose if there is another guy, and I'm showcasing you this with this yellow color, right? If there is another person here who wants to be communicated by this server, and server is the initiator, then if it initiates the point towards this guy, there is no entry with respect to this one, because there is no static entry like one-to-one NAT. And that is why this traffic is going to be discarded exactly here. You're getting my point, right? So from any number of hosts you can reach to internet, and those can be replied because the entries are there. But nobody from outside, if it is the initiator, can reach out to you. But yes, the reply packet is always going to be there. Guys, this is important in understanding tunneling because the next board is totally dependent on this. Any questions on this NAT overload? Satya, Sandeep, any question?
In the NAT overload, it's talking about 10.2.10.x subnets. It's initiated, then connection will establish.
Yes.
If somebody else is initiated, it won't work, right?
Yes. And there is a proper reason for that, because there is not going to be
no entry. Yeah. But in one-to-one, we have both reverse direction as well, right?
Yeah, both, because you have specifically mentioned the entry there, which should be all the times. And that is why basically we are calling it a static NAT. And this is dynamic, you can say.
Yeah, got it.
Okay, good. Murli, Rohit, Ben, all are okay.
Vishnu, just confirm this NAT overload is same as port address translation, right?
Exactly, you are right.
Okay, thank you.
Anything else, guys? Okay. So now, if you understand this, if you know all these things, you shouldn't be having problem. What data tunnels should be up and what is not, right? Now, a simple question from you guys is, I have put now these V edges, and this is the standard design you are going to see everywhere, that V edges are not going to be Means in most of the cases in data center, those are not going to be facing internet directly, right? So I have put this V edge just before just before this firewall, and firewall is responsible for doing the netting part. You're getting my point? Similarly, at the campus side also, here we are having the same thing. And believe me, I do not have static net configured. So static net is not there. This guy is translating whatever the IP address we have, right? And now basically, because you have those concepts in your belt, guys, I am going to ask the question, right? Just use those concepts and do let me know. See, we do not have a static. We have only port address translation. And who is doing that port address translation? This firewall and this firewall. We do not have firewall here, right? Just let me know, can we have a IPsec tunnel between VH2 and VH1? Anybody? Is this tunnel is going to be formed or not formed? If it is going to be formed, then why? If it is not, then why not? Anyone? Just think. Maybe just take your time. Maybe 1 minute, 1.5 minutes. But is this tunnel is going to be formed? Just try to understand. Once again, I'm repeating this thing. Now this firewall which I've shown here is doing the translation. And that is not static, that is port address translation. Can a static tunnel can be formed? Sorry, the IPsec tunnel can be formed. Yes, Murli.
Yeah, Vishnu, if I understand correctly, so as long as both the VH1 and VH2 has the TLOC information with respect to each other, receiving from the vSmart, then there will be a tunnel. There should be an IPsec tunnel between those two. Okay, if I may ask, what is the TLOC information for? Okay, just wait. So you are saying the tunnel will be formed if you have sent the TLOC information. Okay, I'm telling the TLOC information is there. Now tell if the tunnel is going to be formed or not. And by the way, TLOC information is nothing for this VH1. Suppose we have 1.1.1.1 IP, and then basically this color is say black. Okay. So this TLOC information is everywhere. I mean, this guy also know. Suppose this is 2.2.2.2, and this color is black. Okay. So all the TLOCs are here. This guy has advertised. Guys, come on, use your net knowledge. This is nothing new, right? And I am amazed to see that people get confused when I ask this. What do you say, Ashish sir? Whether this tunnel is going to be formed or not? Ashish.
Well, I'm not able to relate the concept wise.
Okay, we will be relating. What about you, Ben? Rohit?
Sorry, Vishnu, sorry. So the question again, I just step out a little bit for something. So can you do the question again, please?
I'm just asking that whether this tunnel is going to be there or not. Whether they can form the tunnel.
No, it is not going to form the tunnel.
Who has said that?
Ram.
Good year. Then there is a problem. What about you, Vanchi? Satya doesn't speak. I don't know why. Sandeep, Pankaj.
It will form.
Yeah, it will form.
Yeah.
Okay. So there is a mixed response. Some people are saying it is formed. Some are saying not. What about you, Pankaj? What do you say?
Yeah, at least in my setup, it does get formed. So what we need to do is tune the firewall rules. That's it, to allow the communication between the VH and vSmart. So.
Okay, this is interesting if it is forming in your setup. Okay. This is really interesting. Yeah. Okay, I'll tell you the reason. It is not going to be formed, right? And let's understand the reason, right? You must your scenario must be something different, Pankaj. But let's see. Let's try to understand from the net concept whatever we have, right? So guys, we are just going to explain that why this tunnel is not going to be formed in this case. Right. So the thought process of Murli was absolutely correct, that if we have these TLOC information, then we are going to form the tunnel, right? If I say what is the meaning of this TLOC information, the meaning is that with this thing, it is going to represent this IP address 10.10.10.10, right? And with this, it is going to send. It is going to say this information 10.10.20.20, which is exactly the IP address configured on this interface and this interface respectively. I think you guys know. And the tunnel should be formed between these two addresses. Correct? Murli, could you please on mute? There is a little bit sound. If you
Sorry.
Right. So so basically the tunnel is going to be formed between this IP address and this IP address, means here and here, which I have shown with this. Now suppose this guy is when this guy go out 10.10.10.10, because I have a port address translation here, it is going to be 1.1.1.1, and here it is going to be 2.2.2.2, right? Suppose VH wants to initiate a connection towards VH2. Which connection, guys? This is going to be IPsec connection, right? Because this is an IPsec tunnel, right? And for that, basically what packet is going to be created? It is going to create a packet which is going to have the source IP address of. Source IP address is going to be 10.10.10.10, and the destination IP address is going to be 10. Or basically somebody has informed him that basically this edge is behind this guy, right? The destination is going to be 2.2.2.2, right? The packet reaches here, and the firewall is going to transfer it, and the firewall is going to change this IP address from 10.10.10.10 to which one? 1.1.1.1. So when it reaches here, right? As I mentioned in port address translation, there is no mapping, although there is a mapping now configured here on this address because it is going from here to here, right? And there somebody has changed the IP address from 10.10.10.10 to 1.1.1. But when it reaches here, there is no mapping here at all, right? There is no mapping where exactly this guy 2.2.2.2 should send this packet to. You are getting my point in case of port address translation. And that is what I mentioned here, that nobody from outside in case of port address translation can reach you because you do not have any translation to begin with, right? And if you don't have any translation to begin with, this packet is exactly dropped once it reaches here. Getting my point, guys? And we will exactly see why this tunnel is going to be formed between VH1 and VH3. I'm going to showcase you this one. Okay.
Vishnu.
Yes, sir.
Sorry, I'm just. Anyway, it will form a control tunnel, right? Initially.
Exactly.
So vSmart having all the source and destination, right?
Yes.
So it will he will give all pass to all this VHs, right?
You are right.
So
but I'm talking about NAT. NAT is different, and NAT is not happening on this VHs, by the way, guys. This vSmart cannot control this guy. NAT is happening on firewall.
So my understanding is, if the vSmart perspective, if I want to reach VH1, okay, so VH1 to VH2, so in the VH1 that IP routes will be, if you want to reach my 10.10.20.20, it will say only 10.10.10, right? So that is the reason the packet is dropping for data tunnel.
No. See, there is no problem with respect to tunnels in the vSmart. vSmart will be receiving all the route, no problems, and it will be sending all the route. And that is why I'm saying that this data center is going to have all the TLOCs information. Similarly, this campus is going to have all the TLOC information. You agree with me?
Yep.
If it is the case, if this campus knows the TLOC information of data center, the first thing first, it is going to initiate the data tunnel. You agree with me? Right? And what is the meaning of this TLOC? TLOC doesn't have any meaning. It has just meaning of IP address, right?
Yeah.
This
next stop.
This is having, it means that the tunnel is going to be formed between these two IP addresses, right?
Correct.
And then I have drawn the packet. Source is going to be this, destination is going to be this, and where exactly it is learning 2.2.2.2, it is interesting. We'll let you know. But for now, let's say this guy knows that for sending to 10.10.20.20, it needs to send it to 2.2.2.2, and it is doing exactly the same thing. The initial communication is started by this VH1, and that is why this firewall, which is here, is doing the NAT correctly. The NAT is done, and the source IP address is going to be 1.1.1.1. It is routed over the internet. It will reach here at this firewall, here, right? At this firewall. Once it reaches there, it won't see any NAT translation with respect to 1.1.1 because nobody has initiated connection in this direction.
Okay.
And if it is nobody has initiated connection in this direction, this packet is going to be dropped. Believe me, guys.
Okay.
So we have to do the static mapping on the firewall?
In this case, yes. Any site, any one site, if you do the static mapping, it is going to work. I'll let you know exactly why. But Pankaj, did you get anything out of it? Why it should not work?
Yes, I fully got the concept, but I was just looking into my firewall configuration, and it is something like
okay.
It is pretty complex. They have created one VRF in transparent mode. They are doing some nettings down there. It's 20-25 lines configuration, and it takes some time to understand me.
No worries.
This is
but believe me, concept is this much simple, guys, and there is how the tunnel should be formed if a NAT is in picture. But yes, we are going to see why VH1 and VH3 tunnel is going to be formed. But I just wanted to know at the first place, are you guys comfortable in this fact that why this tunnel is not going to be formed between VH1 and VH2 unless we do something more? Is everybody is on the same page with me?
Simple answer is there is no mapping with your private IP with the public IP. Means
exactly,
that 10 with the one.
Exactly, this is as simple as this.
Correct. And Vishnu, in normal IPsec, if I'm not wrong, we are defining the interesting traffic, right? That traffic we're excluding from the which IP address to be netted, right?
Man, that traffic portion comes later. First of all, we are just building the tunnel, right? Once we have the tunnel,
normal IPsec also. If there is a normal IPsec,
normal IPsec is going to work like this. Exactly
correct.
Like this.
No, in that interesting traffic, we are excluding from the which IP to be netted, right?
Yes. Or I'm not get your. I didn't get your question. But you are right.
Normal IP, correct. In the normal IP, we are defining the interesting traffic between the two sides, right? Which is from A side to B side. If the interesting traffic, that should be excluded from the net IP address, right? Which are all the
yes. But now here, if we can talk about more about the initial communication, the initial tunnel in SD-WAN.
Okay.
Basically, that is dependent on these settings of NAT, right? Because most of the time you are getting this setting in the actual real production in data center, you are going to get NAT, right? And that is where basically the confusion starts. So I'm just removing all this thing. Maybe with the second thing which I am going to explain you, it is going to make much more sense to you. So this way basically it is not possible. And now we are going to talk about what exactly happens when we trying to form, or when this SD-WAN solution trying to form tunnel between VH1 and VH3. Now my question is, will there be tunnel between VH1 and VH3? There is no firewall involved here at branch 1. No NAT involved at branch 1. There is only NAT involved at data center. What do you guys say?
If VH starts initiating, then yes, it will form this.
Who said that?
Vanchi.
Vanchi, you got the concept absolutely right. Right? If VH1 is initiating the tunnel, it is going to be there. But if VH3 is initiating the tunnel, it is not going, and it doesn't matter who is going to initiate the tunnel should be there, right? So when VH tries to initiate this yellow and yellow tunnel, right? The IPsec tunnel. When it reaches here, it won't be finding the mapping, and if it is if there is no mapping, there is no tunnel is going to be formed. But when VH1 and believe me, guys, both edges try to form a communication because both are going to have the TLOC information with each other, right? So if VH3 is not going to get that connection, that is perfectly fine. But we have VH1, which is going to take the connection, right? It will initiate the connection. The net mapping is here. It will reach here. There is no net here. Perfectly fine. And then basically we are going to go back. We will find the net translation here in this firewall, and the connection will go through, right? It means that IPsec connection is should be good. Now my question is, what we need to do between VH1 and VH2 so that this communication is up and running? Nothing. Simple. If I can configure a one-to-one NAT here on this firewall, that whenever you see 10.10.10.10, just map it to a public IP address. Maybe this guy has also taken a range of IP addresses. Maybe it is having 4.4.4.4. This mapping is always be there, right? This mapping is always be there. So although if this guy initiates a connection, VH1, there is no IPsec tunnel, but as I mentioned that anybody can initiate a tunnel. If there is no tunnel from this direction, this guy, if initiate the connection towards 4.4, it is going to have this one-to-one mapping, and it is going to convert, this firewall is going to convert 4.4.4 into 10.10.10, and that is why basically there is a tunnel form. And the reverse traffic is always permitted, no problems. Tunnel is formed, right? You will see in actual production when you design these networks, the presence of firewalls at both the side. It depends on what NAT configuration you have configured to bring up these tunnels, right? With respect to data tunnels, there is not going to be problem at all because, of course, we are going to initiate a connection from here. When the VH, it is get translated, it will be reaches here, and that is fine because VHs are the one who is always going to start the control connection towards the vSmart. As simple as that, right? Any question? Any doubt, guys?
So if there is a firewall, just the workaround is to map to the static, right?
Yes. If there is a firewall in both the direction, you are doing port address translation. At least one should be having the static map. At least one. Okay.
Vishnu, I'm just going back again. I'm just sorry. If things only VH2, okay? VH2. I'm just brand new boxes. Okay. You said you connected via firewall, right? So the basic SD-WAN, it will there is an internet connection, for example. It will check with my B-bond because we are pointing about my B-bond IP address, right? So from this initial setup itself, we need to do the static NAT to connect the V-bond. The initial setup.
V-bond connection is going to be there for sure because V-bond connection is same as the vSmart connection, right? But your question should be, if I say I am just hiding one thing from you guys, right? The communication between this 10.10.10.10 and the communication between this, I am talking about the IPsec tunnel between this, and this is very, very interesting, right? I am little bit worried that why didn't you guys ask, and I think Vanchi is more closer to you, closer to this question. That when we initiate a tunnel, right, we are going to initiate a tunnel between these two guys because these are the two addresses which are pointed by TLOCs, this address and this address. But now I mentioned that when this VH2 initiate the connection, it is not initiating the connection towards 10.10. Sorry, it is not initiating the connection towards 10.10.10.10. It is initiating the connection towards 4.4.4. where exactly it is getting this 4.4.4.4 instead of this, right? This is the interesting problem. You're getting my point. I mentioned that VH2 is not going to connect to 10.10.10.10 because this is the private address, right? But where exactly it is getting this address 4.4.4, the public mapping, right? And this is where your vBond, the first communication, comes into picture. So vBond has some other responsibilities also, right? It also works as this. It also helps other edges to know public and private IP addresses. And the thing or the server which do all this thing is known as STUN, right? The STUN server, Session Travel Utility for NAT, right? What is the meaning of this? When this VH starts making communication, and guys, try to understand this, right? This is very, very important and very, very good questions too. When this VH, and I am again choosing the pen, this one, yeah. When this VH1 start making connection towards the vBond here, right? It tells in the message, whatever it is sending here, it say that my private IP address is that IP address configured on my immediate interface is 10.10.10.10, right? That is it. But, and then basically this guy also see that the communication is happening over this netted IP address, which is 4.4.4.4. So vBond knows, right? When you want to communicate to 10.10.10.10, right? You are actually trying to be communicating over 4.4.4.4 because this guy know that in the initial message, it says that 10.10.10.10, but the message is coming from 4.4.4. It means that this VH is behind NAT, right? Maybe 1-to-1 or whatever, right? That is why basically when you do show connection, it is going to tell you basically both the IP addresses, public IP address as well as private IP address. And then this vBond is responsible to let this information know to other guys also, to other VHs, right? Or basically to the vSmart, and vSmart is going to be sending all this information. So this VH2 knows that exactly it doesn't need to communicate to 10.10.10.10. It is going to need to communicate to 4.4.4.4. Getting my questions, guys? So vBond has other functions also. And one of the most important function is this stun functionality of the vBond, which is just nothing, which is just to let everybody knows that if a VH is behind NAT device or not. If it is behind NAT device, then basically this is the private IP address and this is the public IP address. As simple as that.
Vishnu, can you tell once again the STUN full form?
Session Travel Utility for NAT. Okay, it is nothing new. It was there previously. We are just making sure that vBond resolves. So vBond is one of the most important piece because everything is going to connect to this guy. This guy knows everything about, and this guy is also responsible for authenticating your VHs so that nobody else can come with their device and fit everything into your fabric. Okay, so last topic of today, and believe me guys, this is totally dependent on NAT, which is direct internet access. I am open for questions also, guys. Means if you just want me to stop right here and ask questions, I am open for that also. But if you say, let's cover this new topic, let's cover this. What do you say? Are you in the situation of getting a new topic right now? Direct internet access?
Vishnu, I'm just dragging you a little bit. I was just scrolling through the configuration, as I said, to the Palo Alto. So what they did specifically, I would like to know the basic setup. So the site there in Germany have two internet pure ISP connections. and this is kind of DC for some of the applications. It's not the complete DC, but it's for some of the applications. So what they did is that instead of buying 4 different, or I would say 3 different internet connections, they have brought two connections. Mm-hmm. So these 2 connections directly terminated on the firewall, and this was from the legacy setup. Mm-hmm. So now so instead of putting the vEdge routers in front of the firewall, it's now sitting behind the firewall.
Yeah.
And what they did is something like that. They created one what I would say. In case of Palo Alto, what we could say virtual firewall, I would say. Mm-hmm. And dedicated some interfaces. Mm-hmm. And at there what they are doing is they are doing nothing. It's technically they are doing nothing. It just the other part of firewall is acting as a pure L2 switch.
And what is the IP address configured on your vEdge? It is public IP address or private IP address?
Yes, it is public IP address.
Then there is no problem.
Then there is no problem. Yes.
Then there is no NAT in picture.
Yes.
Okay.
Yeah.
This is good information. So guys, let's talk about direct internet access. This is not going to be complicated. Yeah, go ahead, please. Ram?
Sorry. In the previous example, in that case, what is the TLOC address? It's a public IP address or the private IP address?
This is interesting. Yeah. In previous example, in this example, you are saying, right?
Correct.
TLOC address is going to be this. No worries. Means if I say the TLOC address is going to be this, but this guy vBond is informed that whenever you start talking to 10.10.10.10, it means that this address has been translated. This is 4.4.4.4. So for me, the TLOC can be anything of this. If you want to initiate a connection, do not do that on this because there is a NAT involved. You cannot reach this guy. You can only reach this guy. TLOC is always going to be this one.
Okay.
But I'm getting some really, really good questions, guys. It means that people are getting it.
Vishnu, Vanchi here. I have some doubt. So, for example, I wanted to try to initiate it. I mean, the file transfer between VH2 to VH3. Okay.
VH2 to VH3. Okay.
So there is a NAT and everything. There is a formed data tunnel, everything. So all of a sudden, my VH2 ISP link goes down.
Okay.
So how the traffic will go? I mean, how the traffic between VH2 and V3, because my color is not matched with VH3, right?
Right now, in this diagram we have only one internet, right? We have only one.
Yes.
So suppose if I so if I have the MPLS also, yes.
Yeah.
So just try to understand this, right? If we do not have direct tunnel, right? This is one of the I would say one of the best question today, guys. So if this tunnel is not there, right? You are saying that how my communication is going to happen over the MPLS, right? And that is where basically when you want to stitch 2 colors to different colors, in this case, here we have green, right?
No. I think you're not. The point is. So what I'm trying to say is, VH2, VH3, we need to communicate, right?
And this data tunnel is not there.
No, data tunnel is formed. For example, it's formed.
Okay? But it goes down, you are saying.
Yeah. So my worry is only the VH2 ISP link goes down.
That is why if this link goes down, then basically this data tunnel is also
down. Yes.
Right?
Yes. Yeah.
This is the question. And now you are asking me that how basically I'm going to reach this.
Yeah.
I got that. Just try to understand whatever I'm saying, right?
Yeah.
So basically now there are 2 different colors, right? Here we have MPLS. Here we have internet. This link is down. VH2 link is down, right? But this is up.
Yep.
If this goes down, then there is no way.
No
obviously.
point. Yeah, I understood.
Right? Yeah. This is up.
Yep.
Right? So what you want to do is now you have 2 different transport and you want to have a communication across them.
Correct.
This is the problem, right?
Yep.
And this is exactly where sometimes this hub and spoke thing comes into picture. This is your data center, right?
Correct.
So let me draw the correct plan. This is your data center. It has connectivity towards your MPLS, and it has connectivity towards your
ISP.
ISP, Internet Service Provider, right? Through this, basically, we have VH3. Now there is no point of discussing VH2 because VH2 is having only MPLS connectivity, right? So now, whatever the rule, so if you and that is where basically, if you want to have this such kind of failure scenario, you need to configure a hub and spoke topology here.
Okay.
Right. So now the VH3 route, whatever the route here, maybe the Z.Z.Z.Z, you are not learning over the direct, basically direct thing. You are learning it via here, right? From the DC, or maybe the DC is advertising the default route to you. It can do, right? So now you are going to create a packet towards Z.Z.Z.Z. You are matching the default route and you are sending this information over the tunnel between DC and VH1 over MPLS. You can do that, correct? Am I right, Vanchi?
Yeah.
And now if it reaches to DC, this DC has the exact route towards Z.Z.Z.Z, which is over the internet connection, right? Now this traffic can go here. Similarly, can come back. Yeah. So yes, now actually you guys are asking the design challenges and design questions. This is good. And basically, if you understand and that is what I always say, if you understand the fundamentals good, the designing part is really easy. So whatever you are saying, Vanchi, this is the one problem which we get across in our design, SD-WAN design. And then this is the way how you stitch two different T-locks, right?
Yeah. This is why will come in the T-lock extension.
No, T-lock extension is slightly different part. I am just talking about here only single router, right? But T-lock extension is a concept which I would like to cover maybe in the next. Because if you get the concept of T-lock, do not worry. We will be getting it.
And another simple silly question. Check this hub and spoke perspective. DC having MPLS and ISP. Okay. Imagine that DSC side internet is failed. How the communication will happen to VH3?
Okay, where DC side, if the internet failure, then basically there is no way.
Okay.
There is no way then, right? Here the ISP you are saying fail, right? Here you are saying this is fail, then there is no way, man.
But VH3 ISP is up, right?
VH3 ISP is up, but basically it is not able to reach over this ISP because ISP is not here. Right? Only MPLS connectivity is there, and MPLS and ISP are not connected at all with each other.
So in this case, we may have a different DC, then we will point it out.
Yes, absolutely.
Wherever
this is the another design.
Okay.
This is the another design choice, and that is why we have two different DCs. This is absolutely fantastic, guys, because these are the discussions which lead you to that why we want to have another DC. Right? This is good. This is good. Anybody else? Any question, guys?
Vishnu, can you please summarize it again, because I fully did not understand what was the question and how it get fixed.
Okay, the question was just if you can see here, Vanchi is saying Vanchi is introducing some things into this topology, right? VH2, and there is a direct tunnel, this tunnel between VH2 and VH3. Now Vanchi is saying we do not have this internet link at all. This internet link is down, right? If this internet link is down, then basically we have internet transport toward VH3, and over that we have formed this data tunnel. Vanchi is saying this is down. I'm saying this is also down because now there is no connectivity, right? There is no data tunnel between VH2 and VH3. Now the question is, how we can reach, how VH3 can reach to VH2 if we do not have that. So then I told him, then in such scenarios, now you have a connectivity via MPLS, but you should be having the hub and spoke topology. You will be sending traffic to the hub first. Maybe it is advertising 0.0.0.0 route to you. And if you want to send a traffic to branch 1, which is maybe maybe Z.Z.Z.Z, So you will be reaching to here. And now this VH1 is having connectivity to what VH3, the data tunnel, over this internet, right? This tunnel is there. Then basically your traffic is routed over this tunnel and then come in, right? Now he's again introducing one more problem. He's saying that what if this is also goes down, the link between this firewall and the internet, right? Then I said that there is no way. Then he's suggesting some solution, and he's saying, what if we can have another data center which is up and running this internet link? Then I said that yes, now you can have connection, because you can go into this data center and then over this connection you can come back. This is the complete summarization of Vanchi's question. But Vanchi, this is the pretty good question, actually, I would say.
So I just want to focus on VH1. So when the packet receives at the VH1, then how it gonna do the lookup? So will that be similar like what it used to do a route lookup for OMP? Like
indeed. See, that is why, suppose you are asking about this VH1. I'll tell you the lookup.
Because in case of the hub router,
I got your question. Just give me 2 minutes. This is your VPN 0. You agree with me?
Yes.
And this is your VPN, say 10, in which whatever the route we are talking about, right?
Yes.
So see, VPN 0 is nothing but just the underlay, right?
Yes.
And whatever the tunnel you are forming from this VPN 10 to another VPN 10 of another router, right?
Yes.
Right. And if I talk that your packet is not even reaching to VPN 10 at the first place, it is going over this tunnel from here, right?
Yes.
But actually, because this is the underlay, this is from the conceptual point of view, this is going like this into this tunnel.
Yes.
But of course, it is going into the VPN 0, right? But I would say this is the underlay and this is the overlay, right?
Yes.
So when you do everything, whenever everything is up and running, your OMP routes are here, right? Exactly here, right? And if branch 1 goes down, I am saying the data center is going to, okay, you are asking about data center route. So in data center, basically, you will be having the route z.z.z.0/24, which is the branch 1 route, via internet transport, correct? And you are going to have one more route, which is this route, VH2 route. Maybe this is y.y.y. This is via MPLS. And now you are sending one route like 0.0.0 to this guy. And that is why the packet reaches to here. You don't have any problem that packet from y.y.y, which is your VH2, reaches to this guy, the data center router, towards the z.z. You don't have any problem with respect to this, right? Packet reaches to data center. Now they have OMP route here to reach z.z.z.z, reach via internet. That is it. You have everything in OMP.
Yes. I was just thinking about there could be any route leaking would be needed from.
No route leaking, because you are only having VPN 10 here. No route leaking. Every route is there. Nothing is there in VPN, because route leaking can be the case, and that is the case when we discuss DIA. You are not sending anything from VPN 10 to VPN 0 in the underlay. If you want to send it in the underlay, then route leaking is required. You are just sending it over the overlay here.
Okay. Sorry. I got it now. So okay, I was okay. So this is how it is configured for the Microsoft Teams here. Okay, I got it.
This is good. Because these are one of the most I know people in SD-WAN, and these are the things which people doesn't know because they cannot visualize things, right? And believe me, just they visualize about it. That here is the VPN 10. From here the tunnel is formed. This is just the underlay. And if you understand this, the next topic, DIA, is very, very easy for you. It is just a 5 minutes topic then. But I do not want to cover now. And the reason is the time is already 9:30.
Yep.
And I want to give your mind slightly break now. Okay?
So Vishnu, this one, z.z.z.0 via internet, it will be in VH2, right? In VH2, right?
Right.
Okay. If VH2 doesn't get the default route from the DC, so in that case, it is not reachable via
No. So,
MPLS.
okay, sorry. This route,
Yeah.
whatever I have wrote is the data center route.
The data center route, same route will reflect in VH2 as well, right?
Here, basically, see, but you are saying, you are right that this route z.z.z.z, he will be saying that it is reachable via 3.3.3, right? The T-log.
Right.
But
Yeah,
the problem
exactly.
is, but the problem is it won't be getting installed in the OMP table. And the reason, you know what? Because next hop is not reachable. Because this is down. That is why it is going to take the route from data center, which is 0.0.0.0. You're getting my point?
Yes.
The normal routing is going to be same if next hop is not reachable. And I'm talking about the BGP. In BGP, the first criteria to install route in routing table is whether you have reachability towards next hop or not. If you don't have reachability towards next hop, means that you cannot install this route at the first place, right? All the algorithms, whatever the BGP algorithms comes next, first thing first, do you have reachability to the next hop or not? And similarly, the OMP works in the similar fashion. But these are good questions, guys. Very good questions. I would like to conclude this session, and I am just stopping recording for this.